Hello students. So today we are going to start with the next topic, that is wave theory of light. In this topic we will follow the same pattern, that is first I will be explaining the theory of this lesson, which will be followed by two steps. The next step after the theory will be CET questions that are asked in previous year's MHT CET examination, and after that the last part of this particular series will be solving the MCQs from the assignment sheet that we have provided, right? So let's begin with the theory section. Okay, so let's start with the topic, wave theory of light, right? So what is meaning of this wave theory of light? Light had different theories, different scientists or different researchers gave different theories about the light. Like in 17th century, Isaac Newton proposed the theory of light called as corpuscular theory, in which he suggested that light travels in form of particles. This is about 17th century, right? 1600 में कुछ तो. And at the same time, Huygens proposed the theory which was called as wave theory of light, in which light travels as a wave. Newton का theory was light travels as particle and light travels as wave was the Huygens theory. Later on, this was 17th century, right? Later on 19th century में 1870s में James Maxwell proposed the electromagnetic theory, electromagnetic waves. Light travels in the form of electromagnetic waves. This theory was proposed, and in the starting of 20th century, that is 1900 के starting में ही Max Planck suggested the quantum theory, that is light travels as a energy packets. So this lesson particularly focuses on the wave theory of light. So इस lesson में we will be focusing only on this part, that is Huygens wave theory of light. We are not concerned about Max Planck's quantum theory क्या है, Maxwell's electromagnetic theory क्या है, या फिर Newton's corpuscular theory क्या है. But even though syllabus में Newton's corpuscular theory के बारे में somewhat data is given, so I suggest कि you should read that data from the book कि light कैसे travel करती है according to Newton. Okay, so that part is completely theoretical, but major questions will be asked on the wave theory of light, that is Huygens wave theory of light. Remember, these two theories were in the same time, उसी range में थे 1700 के. These two theories were completely different, right? But these two theories were during the same time, so इनमें ज़्यादा conflict था. And later on, experimentally it was proved that कि ये theory गलत है. This theory was finally accepted. But later on, उसके बाद भी अलग-अलग theories आई. And right now, which theory do we have? Anyone knows? Which theory of light do we have right now, or we accept? Which is the theory? Okay, the name of that theory, there is no particular single theory. We know that light has got a dual nature. Means light can travel as a wave as well as light can travel as a particle. So right now our present knowledge, according to the present knowledge that we have, we know that light has got a dual nature. It travels in form of particles as well as it travels in form of a wave, depending on which particular concept that we are explaining. Like if we are explaining reflection, wave theory is enough to explain the reflection. But if you are explaining photoelectric effect, for that wave nature won't be sufficient to explain it. In that case, we need particle nature. So light has got dual nature, that is it can travel as a wave as well as it can travel as a particle. So majorly the lesson wave theory of light focuses on which part? It only focuses on Huygens wave theory. उसमें जो गलत चीजें बताई है, उसमें जो right चीजें बताई है, everything we are going to discuss. But only which theory? Huygens. Okay, we don't have other parts in syllabus directly. Yes, they have mentioned these theories in the introduction part, but expected questions are on the wave theory. So let us go into the detail of this part, that is the wave theory of light. Okay, so now we will probe into the theory, wave theory specifically. So what was Huygens wave theory? That was given in 1700. In the 17th century. What was the Huygens wave theory? The basic content, basic idea about the theory was, these were some points that was given by Huygens that we will discuss. Okay, according to Huygens, नाम में ही लिखा है wave theory, means according to Huygens light travels in form of wave. Obviously first point will be light travels in form of wave, but Huygens suggested that light travels in form of longitudinal waves. Now this is very important. Light travels in form of longitudinal. There are two types of waves, transverse and longitudinal. So Huygens suggested कि light जो wave है वो longitudinal wave है. Means उसमें compressions, rarefaction ऐसे होते हैं. Means the particles of light or medium will vibrate parallel to the direction of propagation. This was the suggestion of Huygens wave theory. So first point is light travels in form of longitudinal wave. Second point is, why do we get different colors of light? Why do we get 7 different colors Vibgyor? Because there are different wavelengths. This was the suggestion by Huygens, that different colors are because of different wavelengths. Smaller wavelength, blue color. Larger wavelength, red color. So different colors because of different wavelengths was the second point. Third point is, we get sensation of light when the light enters the eye. Now you will think, ये क्या point है? ये तो obvious है कि we will see the light only when it will enter the eye. But normally you can think it in this way. See, when a wave is traveling, for example, एक string है और string पे wave is traveling. Even though वो string से wave इस direction में जा रही है, but I can see that wave, right? Even though it is not coming towards my eye, it is going from side. I can see that wave. But light wave में you cannot see that light wave is traveling in this way. Okay? You cannot see a light traveling. Light can only be seen when it enters the eye, right? So this is a very important point, that we get sensation of light when it enters the eye. If it goes past, ऐसे जाएगा, I cannot see that light कि ऐसे गई. I cannot see it. Okay? So light can only be seen when it will enter the eye, not when it will go through side. So third point is, we get sensation of light when the light enters the eye. And the fourth point was very much important, that that in that time Huygens को other scientists asked, Huygens को उन्होंने पूछा कि what if light is a longitudinal wave, then how the light can travel in vacuum? For example, sun और earth के बीच में there is vacuum, there is no medium. If you say, what other scientists asked was, if you say that light is a wave, fine, light is a wave. Then if light is a wave, then how light can travel from sun to earth, even though there is no medium? Even though there is no medium, how wave can travel? Because उस time का understanding ऐसे था कि wave के लिए matter और medium is compulsory. Without medium कोई wave travel ही नहीं कर सकती. Because उस time जो भी wave का explanation या जो भी wave का study था, that suggested कि wave के लिए medium important है. जैसे water के waves, air में waves, string में waves, all these waves require medium. And Huygens said light भी wave है. So light भी अगर wave है, then sun to earth, how light can travel if there is a vacuum between? So just to explain this particular concept, Huygens made up this point. What Huygens said was कि बाबा sun और earth के बीच में there is no vacuum, there is imaginary medium present everywhere in the space, and that imaginary medium was called as luminiferous ether. उसने उसको नाम दे दिया luminiferous ether. Luminiferous ether is present everywhere in the space. Vacuum में भी है और earth पे भी, मतलब matter में भी वो medium है, it is everywhere, it is present. Just to make sure कि उसका theory work करेगा, he just made up this point. That was the point of luminiferous ether. So scientists tried to detect that particular thing, luminiferous ether. Detect करने के लिए different experiments were done, but no presence of luminiferous ether was found. Yes, to make it even difficult, उसको find करना difficult होना चाहिए. To make it difficult to find them, he gave it very difficult properties like perfect transparency, zero density, ऐसे properties दे दिए जिससे वो find करना भी it will become very difficult. But finally it was accepted कि ऐसे कुछ नहीं होता. This is wrong point. But in the theory we have to remember that these were the 4 points in the Huygens wave theory of light. What were the 4 points? Just we will quickly revise. First, light travels in form of longitudinal waves. Second, different colors are because of different wavelength. Third, we get only the sensation of light when it enters the eye. Fourth is light. In order to explain the propagation through vacuum, he assumed hypothetical medium called luminiferous ether, and this was obviously the wrong point. Experimentally, there was no ether detected, right? So, इस theory में there were some positives and some negatives. इस theory से what positive point we can take? So, इस theory में positive points were, this theory के merits are, this theory could explain reflection of light, it could explain refraction of light, it could explain interference, diffraction. ये सब points this theory could explain, because ये तो सब points, ये सब properties wave के हैं ना, and light is a wave, and light is a wave. ये theory का statement ही वो है कि light is a wave and waves should show these properties. So obviously light showed these properties, and this theory could explain reflection, refraction, interference, diffraction. This theory also supported the concept that denser का speed is less, rarer का speed is more, which was experimentally proved correct later on. कि denser में light goes slowly, rarer में it can go very quickly. Okay, so this was also correct according to the theory. These were merit points. Demerits में what were the problem with this theory? पहला problem पहले statement में कि light is not a longitudinal wave. Light is actually, now we know that electromagnetic theory से कि light is a transverse electromagnetic. उसमें इलेक्ट्रिक फील्ड वाइब्रेट होती है इस प्लेन में, इलेक्ट्रिक फील्ड एंड मैग्नेटिक फील्ड वाइब्रेट होती है इस प्लेन में, एंड लाइट ट्रेवल स्ट्रेट, करेक्ट. So now we know that light is a transverse electromagnetic, it is not a longitudinal, so this was the wrong point. Demerit. Light longitudinal hai, it is wrong. This theory could not explain polarization. Polarization we are going to discuss in this topic at the end. Polarization basically you must know that कि polarization सिर्फ transverse wave ही दिखा सकते हैं, longitudinal cannot. So अगर Huygens says that कि light is a longitudinal, how it can explain polarization? Because polarization ये तो transverse का property, but actual में light gets polarized. So Huygens theory could not explain that concept how light can get polarized. Third is no ether. Already I have explained ether कुछ नहीं, just the point was made up in order to explain how light can propagate from sun to earth. Rectilinear propagation. Rectilinear propagation means light travels in a straight line with a very large speed. Okay, so straight line motion of light could not be explained. And last point was wave theory could not explain these particular effects. Now these effects were not at that time, 17th century में ये effects नहीं study किए थे, but after these effects were studied, this theory was tried to be applied on those effects. कि वो photoelectric effect, can I study this effect using the wave theory? They tried the wave theory on these effects, but there was no use of it. This theory could not explain these effects. कौन से हैं वो? Photoelectric effect, Compton effect, and Raman effect. These effects Huygens could not explain. So all these points were demerits of the wave theory of light. Okay, so in this important point, what you must know is wave theory में Huygens का statement क्या था? Huygens said that light is a longitudinal wave, different colors are because of different wavelengths. When do we see light? When it enters the eye, and luminiferous ether is present everywhere. So medium का scene नहीं है कुछ. Merits में what he could explain? Reflection, refraction, interference, diffraction. And denser में speed is greater than rarer. Demerits, problems with the theory were this. Okay, so just pause the video and write down these points if you want. We will move to the next section of this theory. Okay, so the next point is wavefront and wave normal. These were two important terms because we need these terms for further explanation of this theory. What is meaning of wavefront? See, what is the meaning of wavefront? If you have a source of light, for example, ये bulb है or a source of light है, and from this source of light, if I place the source at the center, the waves will start traveling in all the direction. One will come towards you, other will go back, right, left, up, down. Everywhere the waves will start traveling, right? So as the wave will start traveling in all direction, at certain time t, after certain time t, if I stop the time, what you will experience or what you will see is ये सब waves जो t equal to 0 को source से निकले थे, that the waves that emitted through the source at t equal to 0 will reach equal distance c into t. Speed of light है c and time t. So speed into time किया तो क्या मिलेगा? Distance is equal to speed into time. So ct इतना distance, सब distance में, सब direction में they will cover the same distance, that is ct. So at t equal to 0, if you switch on the bulb, the light will start emitting in all direction. At t equal to t, time t के बाद if you stop the time, what you will experience is you will get a sphere of that light. एक light का sphere बनेगा. उसके नीचे दूसरा sphere is coming. उसके नीचे third sphere is coming. So all these spherical things these are imaginary things, right? But all these spheres are called as wavefront. This is a wavefront basically. Okay, this is a spherical wavefront. ये sphere shape का wavefront है. So it is called as spherical wavefront. How to make a spherical wavefront? Just take a point source में से जो light निकलेगी, that will automatically form a spherical wavefront. If you increase the time, तो ये sphere और बड़ा बनेगा. This will just grow in size, right? It will keep on growing in size. So sphere will grow in size. और बहुत देर, after a long amount of time, this sphere का small section if you consider, बड़े sphere का if you take a small part, it will almost be a plane wavefront. It will almost be a plane wavefront. जैसे Earth is very large sphere, but Earth पे if you take a small piece of land, it is almost a plane because the radius of Earth is so large that the curvature is negligible for smaller distances or smaller areas. Similarly, if a point source is taken and from that point source, if the light starts traveling, it will form which wavefront? This wavefront will be spherical wavefront. But after large amount of time, उस spherical wavefront का small section will be a plane wavefront. Okay, so these are some basic terms that you must know. What is the meaning of wavefront? Wavefront is the locus of points where the wave reaches simultaneously so that all points are in the same phase. इसका मीनिंग ऐसे है कि अगर यहाँ से वेवफ्रंट पे अगर क्रेस्ट जाता है, यहाँ पे क्रेस्ट, everywhere you will find there is a crest. Everywhere there will be a crest. All the points are in the same state of the vibration. Right? So this is the meaning of wavefront. Wavefront तीन टाइप के होते हैं, spherical, plane and cylindrical. How to make a spherical wavefront? Take a point source, you will get a spherical wavefront. How to make a plane wavefront? Those options है. Take a point source and wait for a large amount of time. It will form a very large spherical wavefront. उसका small section will be a plane wavefront, right? उसका small section will be a plane wavefront. But plane wavefront बनाने के लिए one more method is there, and that one more method is take a convex lens and convex lens के focus of convex lens पे place that point object. If you place a point object on the focus of a convex lens, what do we observe? The refracted waves will be parallel and the wavefront will be a plane wavefront. So plane wavefront दो मेथड से बना सकते हैं. First method is point source at infinity or point source on the focus of a convex lens. How to make a spherical wavefront? Only one method. Take a point source. You will automatically get a spherical wavefront. And last is cylindrical wavefront. Cylindrical wavefront कैसे बना सकते हैं? If you take a tube light, linear, एक tube light linear source है, उसमें से waves कैसे निकलेंगे बाहर? They will come out like cylindrically, right? यहाँ से ऊपर से बंद होती है tube light, यहाँ से बंद. So only the rays will come out in this way. Means if I have this is a light source, if I have light source in this way, the rays will only come out in this way, right? So it will form a cylindrical shape. So that type of wavefront is called as cylindrical wavefront. So wavefront are of three types, और इन तीनों टाइप में how to make them you must know this. वेव नॉर्मल क्या होता है? वेव नॉर्मल बेसिकली वेवफ्रंट को जो परपेंडिकुलर होता है ना, उसको बोलते हैं वेव नॉर्मल. वेव नॉर्मल क्या है? वेवफ्रंट को परपेंडिकुलर कौन से डायरेक्शन में, इस डायरेक्शन में परपेंडिकुलर या उस डायरेक्शन में, ऑलवेज ड्रॉ परपेंडिकुलर इन द डायरेक्शन ऑफ द प्रोपगेशन. मतलब बाहर है वेव नॉर्मल, सब वेव नॉर्मल्स बाहर है. स्फेरिकल में वेव नॉर्मल ऐसे रेडियली बाहर होंगे बिकॉज इट इज परपेंडिकुलर टू द सरफेस एवरीवेयर, राइट? इवन सिलेंड्रिकल में वेव नॉर्मल ऐसे परपेंडिकुलर दे विल कम आउट. सो वेवफ्रंट एंड वेव नॉर्मल का बेसिक नॉलेज यू मस्ट हैव इन ऑर्डर टू प्रोसीड फॉर द थियरी, फॉर द वेव थियरी का प्रिंसिपल, राइट? Well, so the next point of this lesson is the principle, Huygens Principle, that we will use for construction of spherical wavefront and plane wavefront. So, what is the principle? What is Huygens Principle? It states that every point on spherical wavefront, spherical is not important, every point on wavefront acts as a secondary source of light. Every point on wavefront. For example, ये source है, इसमें से waves are coming out, okay, waves are coming out, and if I say थोड़ी देर के बाद ये wavefront बन गया. इतना कौन सा wavefront है ये wavefront है spherical wavefront. ये spherical wavefront अगर है तो every point on this wavefront मतलब इस wavefront पे जितने point है, infinite point है, right? Every point on this wavefront will think कि वो खुद ही एक source है. This point will think कि वो खुद source है. This will think it is source itself. So this point which is on the wavefront will act as a secondary source and it will emit secondary waves. So अगर ये खुद source है, it will start emitting waves in all direction according to the theory. It will start emitting waves in all direction. So उनके छोटे छोटे wavelets बनेंगे, उनके छोटे छोटे wavefronts बनेंगे जिनको wavelets बोलते हैं, करेक्ट? वो जो wavelets बन रहे हैं वो second point के अकॉर्डिंग दे आर मोर इफेक्टिव इन फॉरवर्ड डायरेक्शन. सो पीछे ज्यादा नहीं आएंगे, इसलिए टॉर्च इधर मारा तो टॉर्च का लाइट पीछे नहीं जाता, सिर्फ आगे ही जाएगा बिकॉज दे आर मोर इफेक्टिव इन फॉरवर्ड डायरेक्शन. दिस इज नाउ द थियरी पार्ट, ओके? सो दे आर मोर इफेक्टिव इन फॉरवर्ड डायरेक्शन, दे आर नॉट गोइंग बैक. एंड अकॉर्डिंग टू द थर्ड पॉइंट, द रिजल्टेंट, ये जो वेवफ्रंट ब्लैक कलर का वेवफ्रंट है ना, ये रिजल्टेंट कहां पे गया? तो जस्ट ड्रॉ द टेंजेंट्स टू दिस न्यू वेवलेंट्स. इफ आई ड्रॉ टेंजेंट टू दिस वेवलेट्स आई विल गेट कि बाबा ये वेवफ्रंट ओल्ड था, अभी वेवफ्रंट का पोजीशन चेंज होके ये इधर तक गया है. सिमिलरली वो आगे बढ़ेगा, इस पे एवरी पॉइंट विल एक्ट एज सेकेंडरी वेव्स, दे विल एमिट सेकेंडरी वेव्स, उनको टेंजेंट ड्रॉ किया. सो इन दिस वे द वेवलेट विल कीप ऑन प्रोपगेटिंग इन द स्पेस. This is not only for spherical, also true for plane, also true for cylindrical. I have just explained it for spherical wavefront. So Huygens principle में whether these 3 points are clear कि first point is कोई भी wavefront पे there are infinite number of points, each point will behave कि वो खुद एक source है and it will emit secondary waves in all direction. But all direction में ज्यादा effective कौन सी direction में है? Forward direction. मतलब source पीछे है तो right direction, forward direction. And then resultant wavefront कहां तक गया है? That can be shown by drawing the tangent to these new wavelets. That will give you the position of the resultant wavefront. This is Huygens principle, which we use for parallel and this we use for explanation of reflection and refraction of light. Theory section में if you remember theory part में board exam में दो derivation important थे इस lesson में से. एक reflection था जिसका diagram बहुत difficult था draw करने के लिए, right? उसमें confusion होता था. Actually it is very simple. And the second point was refraction of light जिसमें light enter करता है दूसरे medium में. So these 2 points are not expected for derivation in the CET exam. What you must know in these two now कि उस दोनों में reflection and refraction में you must know the concept and you must know the formula. Okay? So Huygens principle के बाद next point is reflection and refraction of light. Okay, so the next point is reflection of light, and this figure we have seen for the board exams. We have derived the relation I equal to R. But for MCQ, what you must know? Yes, I, angle of incidence, is equal to angle of reflection in case of reflection of light. And second important thing is this blue color. What is this blue color line? Blue color ka line. This line is called as width of wavefront. Width of wavefront. ये wavefront का width है, right? ये width reflection के बाद भी same ही रहता है. So width of incident and width of reflected is same. There is no change in the width. Refraction में we will see कि width will increase or either it will decrease. Depend करता है कौन से medium से कौन से medium में जाता. But in case of reflection, the width remains same. Angle of incidence is equal to angle of reflection. Everything is good. Reflection का normal theory you already know कि laws of reflection and all. बाकी reflection there is nothing else. This is what you must know in reflection. Okay? So we will move to refraction now. Okay, so the next point is refraction of light. And in refraction, this is the figure. The ray of light is incident. This blue color thing is the wavefront, plane wavefront. The plane wavefront is incident, and after refraction, it bends towards the normal because it is entering from rarer to denser. If it enters from denser to rarer, it will go away from normal. Now you can see that the wavefront ka width is increased, right? Wavefront ka width has increased, and this angle should be R. This angle is R, and you can relate these wavefront. But before relating these wavefront, first we will study some basic formula that you already know. What is sin I by sin R? Sin I by sin R is equal to refractive index of 2 with respect to 1. ये कैसे लिखना है? When the light is traveling from 1 to 2. This is how to read this refractive index of medium 2 with respect to medium 1. But learning this formula is not, so you can learn this formula easily, but it is not useful in case of difficult questions. So instead of learning this form of Snell's law, it is always good to learn it in this way. N1, or we use mu for refractive index, right? Mu1 sin theta 1 is equal to mu2 sin theta 2. This version of Snell's law is easier to remember and easy to apply. Later on you will see this thing. Ki light is entering from which medium to which medium we don't know, but angles are given alpha, beta, refractive mu1 and mu2. And पूछा है कि what is sin alpha by sin beta? Sin alpha by sin beta. Then which mu I should take in the numerator? Mu2 or mu1? In this case, you can use Snell's law directly if you know it, but this version of Snell's law will be more useful. कैसे? Because refractive index of this medium into sine of angle of the same medium is equal to refractive index of this medium into sine of angle of the same medium. This is easier to learn because you don't know where light is going. यहाँ से यहाँ जा रही, यहाँ से यहाँ जा रही. You don't know the direction of the ray. So how you can comment कि what is angle of incidence or what is angle of refraction? So confusion हो जाता है. If you know Snell's law well, even this version is good. But this version will help you to solve numericals more quickly. So remember it in this way. Mu1 sin theta 1 equals to mu2 sin theta 2. Now see, if you know this refractive index ka formula, there are different variations. Okay? And what are those variations? I'll explain. Sin theta 1, which is sin I, by sin R will be equal, or sin r is sin theta 2 will be equal to, it will be equal to what? Sin theta 1 upon sin theta 2 will be, that is sin I by sin r will be mu 2 cross multiply upon mu 1. This will go down, correct? And mu 2 by mu 1 is mu 2 1, right? It is equal to mu 2 by mu 1 is mu 2 1 is equal to speed of light in medium 1 upon speed of light in medium 2. This is definition, ratio of speed of lights, and it is equal to wavelength of light in medium 1 upon wavelength of light in medium 2. Because frequency, whenever light changes the medium, the quantity that never changes, speed, wavelength, frequency, which quantity will not change if light goes from first medium to second medium? तो यहाँ पे speed c1 है ना, तो this will become c2. यहाँ पे wavelength lambda 1 है ना, तो यहाँ पे wavelength will become lambda 2, but frequency will remain same. अब यहाँ पे frequency f है, यहाँ पे भी frequency f है, so frequency will never change. So from c1 by c2 it converts to lambda 1 by lambda 2, and it can also be written as 1 upon mu 1 2 by interchanging this, right? So these are some formulae that we need for solving questions. Remember CET के लिए wave theory में questions जो है, similar questions you will also find in refraction of light of 11th standard. 11th standard में topic है refraction of light. During that time we will revise this formula once again. उसमें थोड़ा ज़्यादा detailing है. यहाँ पे just I am giving you the formula that this is the relation between all these terms. If numerical comes you can solve it. But उससे ज़्यादा important अभी ये है width का concept. If the question is what is width का ratio in medium 1 to medium 2, how you can derive it? Width in medium 1 upon width in medium 2 can be derived it in this way. I will just divide width by this common length. Let us call this common length as d. ये common length जो दोनों में common है, दोनों triangles में, this is 90 degree, this is 90 degree. So width 1 upon d upon width 2 upon d, width 1 upon d upon width 2 upon d will be equal to cos I by cos r, and this is the formula of width 1 upon width 2. Width in first medium upon width in second medium is cos of angle in first medium upon cos of angle in second medium. This will help you to solve questions regarding width. Refraction में the normal mistake that student will do is, question में ऐसे लिखा है a ray of light. See, just focus on what I am giving the question. The question is, the ray of light is incident and it is making 60 degree with vertical. So 60 degree with vertical when a ray of light makes, what is that angle called as? It is called as angle of incidence. If I give you it in this way, if a ray of light is incident and it makes 30 degree with surface, then we know that this is not the angle of incidence, this is angle of glance. How to convert it into angle of incidence? इसका complementary 90 minus ये angle 30 will give you 60. So everything is okay when the ray of light is given. When the ray of light is incident, this is angle of incidence, this is angle of refract, angle of glance. ये glancing angle है, which is of no use. इसको convert करना पड़ता है I में. But इसमें problem आता है कि question में it will be given in this way. Question में a wavefront is incident, right? Not a ray. Ray नहीं, wavefront is incident. देखो wavefront is coming towards the surface. Wavefront is incident, and when the wavefront is incident, that wavefront is making angle 60 degree with the surface. Wavefront is making 60 degree with the surface. Then what you will think? अरे with the surface है, इसको complementary करके I में convert करते हैं. But remember, when a wavefront का angle with the surface is given, that itself is the angle of incidence, right? That itself is the angle of incidence. इसको फिर से convert करके यहाँ नहीं लाना. When the wavefront makes angle with the surface, that angle itself is angle of incidence. हाँ, यहाँ पे trick कैसे कब use करेंगे? If a wavefront is making angle 30 degree with the normal, wavefront का angle with the normal अगर दिया है, in that case you have to convert it into angle of incidence by taking the complementary, that is 90 minus वो angle करके. जैसे इस question में when the wavefront is incident, ये wavefront ऐसे incident हुआ, and wavefront is making 20 degree with the normal, then what is angle of incidence? It is not 20, it is 70. Angle of incidence is the angle made by wavefront with the surface. Very important. Normally student make mistakes over here, so I have covered that part as well. So whether refraction of light part is covered, whether it is clear. So we will move to the next point and the last point, that is polarization, and उसके बाद Dopplers effect. Okay, so the next point is polarization of light, right? So what is polarization of light? This point we have seen in wave theory ka demerits, that Huygens theory could not explain polarization of light. और तभी मैंने क्या explanation दिया था? Polarization ये ऐसा property है which is only shown by transverse waves and not by longitudinal. So according to Huygens, light is longitudinal. So obviously according to Huygens, अगर light longitudinal है, how it would show polarization? Polarization तो transverse का property है. So polarization होता क्या है? What is polarization? So consider करो, एक यहां से एक rope है. From this point there is a rope which is coming towards you, right? A single rope. और उस rope पे if I hold it from this end and if I oscillate, what you will see? If a rope is coming towards you, if I oscillate it from this end, what you will see? You won't see the rope. When the rope is at rest, you will only see a dot coming towards you, right? And when I will start oscillating it in this way, the vibrations you will see in this way. You will see a straight line. अगर बड़ा oscillation किया, तो you will see a big line. And small oscillations, if I do small oscillation, you will see a small line. Correct? You will never see a rope because you are viewing from this end, and from this end the rope is exactly perpendicular. So your eye, right, from your eye you cannot see this part because ऐसे ray तो नहीं आएंगी, right? If you are seeing from side, then you can see the whole rope, but I am considering it right straight. So when the rope is exactly straight, and if I am oscillating it in this way, you see a straight line, correct? Now instead of now if I oscillate it in this way, you will see this dot vibrating in this way, means you will see horizontal, correct? Now instead of a single rope, from this point, if I send 100 ropes, 100 threads, right? First thread को मैंने ऐसा oscillate किया, so you will see vertical line of the first thread. Second को horizontal, third को inclined, fourth को ऐसे inclined, fifth को थोड़ा अलग angle से, sixth को अलग angle से. So what you will see basically, when I was not vibrating any string, 100 string you will see in this way, 100 string coming towards you, 100 dots, correct? So basically you will see this single spot coming towards you. But when I will start vibrating उनमें से एक string अलग-अलग direction में, you will see this type of structure coming towards you. This type of structure. बराबर? So this particular wave which is coming towards you is called as unpolarized wave. Unpolarized wave. Unpolarized wave is coming towards you right now. Okay? Now, what I will do is, when the wave is coming towards you unpolarized, I will put a cardboard in between. और उस cardboard में there is only a vertical slit cut in the cardboard. And when these all vibrations are coming towards you, I will place a slit between ये वाला. तो इनमें से horizontal वाले जो vibrations हैं, those vibrations will cut out, stop हो जाएंगे वो. Vertical वाले बाहर निकलेंगे. Just think what will happen to these inclined वाले vibrations. ये inclined vibrations जो है ना, उनका क्या होगा? तो inclined vibration का एक component जो होता है ये वाला, this component will come out and this component will cut because of this slit. इस वाले का भी ये component आएगा, ये component cancel हो जाएगा. So everyone, all those 100 threads के vertical components will come out, horizontal will cancel. और अगर intensity के बारे में बात करते हैं, अगर इसका strength 100 है, 100 units इसका strength है, okay? So after passing through this, इनके सबके component लेके, the strength straight away drops to half, the strength becomes 50, intensity directly half हो जाती है. लेकिन इस wave, अभी इसमें से जो wave बाहर आएगी, वो कैसे दिखेगी? It will only come out vertical, only vertical vibrations will come out. अब इस cardboard को मैंने और rotate किया थोड़ा सा, ऐसे. If I rotate the cardboard in this way, तो ये slit भी rotate हो जाएगी इसके साथ. So now the vibrations that are coming towards you are in this way. These vibrations will come towards you. Correct? So this process of converting this unpolarized wave into vibrations in a single plane, ये single plane vibration में convert कर दिया, right? This process is called as polarization. And the wave that we have converted is called as polarized wave. ये polarized wave है. ये अनपोलराइज्ड वेव थी जिसमें ऑल डायरेक्शन में वाइब्रेशंस प्रेजेंट थे, उनको एक डायरेक्शन में कन्वर्ट करने का जो प्रोसेस है, दैट प्रोसेस इज कॉल्ड एज पोलराइजेशन एंड द फाइनल आउटपुट इज कॉल्ड एज पोलराइज्ड वेव और प्लेन पोलराइज्ड वेव। प्लेन पोलराइज्ड क्यों बोलते हैं? बिकॉज वो एक प्लेन में वाइब्रेशंस अभी प्रेजेंट है, सब इसी प्लेन में वाइब्रेट होते होते आएंगे। पहले इट वाज वाइब्रेटिंग इन ऑल डायरेक्शन, देन अ स्लिट इज प्रेजेंट, स्लिट में से जब निकलेंगे दे विल ओनली कम वाइब्रेटिंग in a particular plane, so they are named as plane polarized wave. Intensity drops to half, very important, intensity drops to half. Now see, इसमें थोड़ा we will go in details now. In polarization, further what happens? See, okay, so now once you know what is meaning of polarization, how to polarize something, let us consider this particular wave. Tell me whether it is polarized or unpolarized. ये wave polarized है या unpolarized है? This wave is unpolarized, correct? And if I pass it through a vertical slit, cut ऐसे है, इसमें से pass किया, then the thing that will come out will be a plane polarized wave, correct? So this is the symbol of plane polarized, this is the symbol of unpolarized, and this substance, this material or this object is called as slit, इसको कहते हैं, right? But it is called as polarizer. So polarizer is the object which can convert unpolarized wave to polarized wave. Now think on this, if this is unpolarized wave, इसके आगे रख दिया polarizer, slit वाला, what wave is coming out? ऐसे वाली wave. If I place one more polarizer, ये polarizer है क्या? This is a polarizer. And if I place one more polarizer in front of it, उसमें से भी सब वेव जाएंगे. Why all waves will come out? Because इसका slit का orientation और इसके slit का orientation parallel है एक दूसरे को. Means see, if this is the first slit और ये vertical ऐसे है cut, इसमें से निकल रहे, दूसरा भी वैसे, उसका भी vertical cut है. So both unpolarized में से wave आई, polarized हो गई. Second slit इसमें से भी straight the wave will come out. But think on this, if I rotate this, what will happen? इसमें से 100 इंटेंसिटी आई थी, इसमें से जब बाहर निकलेंगी वेव, तो इस वेव का इंटेंसिटी 50 है. वी हैव ऑलरेडी डिस्कस्ड अनपोलराइज्ड का पोलराइज्ड इंटेंसिटी बिकम्स हाफ. सेकेंड पोलराइजर में जब पास किया मैंने, व्हेन दे वर पैरेलल, इनमें एंगल कितना था? 0 डिग्री एंगल था, तो ऑल द वेव्स वर कमिंग आउट, 50 इंटेंसिटी है. लेकिन अगर मैं इस पोलराइजर को, इफ आई रोटेट इट, इफ आई स्टार्ट रोटेटिंग, उनके बीच में 10 डिग्री, 20 डिग्री, 30 डिग्री, 40 डिग्री, 50 डिग्री, 60 डिग्री, एंड इफ आई मेक इट 90 डिग्री, व्हाट विल हैपन? इफ आई मेक द एंगल एज 90 डिग्री, नॉट इवन अ सिंगल वेव विल कम आउट, करेक्ट? Why not even a single ray will come out? Because when the waves are vibrating perpendicular in this way, and if I place a polarizer sheet in this way, certain angle को, so इसका cos component पास हो रहा है ना इसमें से, इसका cos component, but 90 डिग्री में cos 90 तो 0 होता है. So when you place the second sheet perpendicular to the first, second polarizer first polarizer को perpendicular है, not even a single light will pass, so intensity will become 0, right? So this polarizer, second polarizer rotate करने के बाद इंटेंसिटी यहाँ पे चेंज होती है फिर से. और इफ यू कंटिन्यू, 0 है, यहां से इंटेंसिटी कितनी आई? 100, यहां से 50. सेकेंड पोलराइजर स्ट्रेट रखा है तो ये भी 50. अब तुम्हारे इधर 50, इट इज कमिंग 50 टुवर्ड्स यू, राइट? इफ आई स्टार्ट रोटेटिंग दिस, यू विल फाइंड 40, 30, 20, 10 and then 0, correct? Because 90 degree है. Now further if I keep on increasing, again it will become 10, 20, 30, 40, 50. Again it will become 50. Again if I continue rotating, again it will become 0. So 0 to 50, 50 to 0, 0 to 50. This, as angle is changing, the intensity will change. And the intensity coming out is given as I naught. ये I naught है, original intensity का half. 50 तो यहाँ पे हुआ I naught by 2 cos square theta. This is the intensity coming out from the second polarizer, which we call it as a analyzer. It is analyzer. It analyzes कि light polarized है या नहीं. This is a polarizer which polarizes the light. उसने polarize करने के बाद second sheet check कर दी कि उसने correctly polarize किया है. अगर 0 आता है मतलब correctly polarize किया है. अगर 0 नहीं आता है, it means इसने अच्छे से polarize नहीं किया है. So second is analyzer, and the intensity coming out, resultant intensity coming out is given by original I naught. I naught is unpolarized light का intensity. Unpolarized light का intensity upon 2 cos square theta. This is called as Maharashtra law. Okay, syllabus में नहीं है लेकिन you must know this basic things. बहुत difficult भी नहीं है. So in polarization, first whether this is clear कि what is meaning of polarization, what is unpolarized light, what is polarized light. Now we will move to methods of polarization of light. अभी तक लाइट का पोलराइजेशन नहीं किया था, वेव का किया था. वेव मतलब नॉर्मल वेव, स्ट्रिंग के ऊपर की वेव. लाइट का पोलराइजेशन इज समथिंग डिफरेंट. ओके, सो वी विल मूव टू द नेक्स्ट पॉइंट, दैट इज पोलराइजेशन ऑफ लाइट, उसके मेथड्स. ओके, सो बिफोर वी मूव टू द मेथड्स ऑफ पोलराइजेशन ऑफ लाइट, फर्स्ट वी विल जस्ट cover 2 points, what is plane of vibration and plane of polarization. See, again I'll come back to that example. When a sheet is held in this way, I said that unpolarized light, यहाँ से आई, all the light was polarized. This plane जिसमें vibrations present होते हैं, जिस plane में vibrations are present, that plane is called as plane of vibration. और जिस plane में, मतलब इस plane को perpendicular, ये जो plane है, जिसमें एक भी vibration present नहीं होता है, that plane is called as plane of polarization, right? So these were 2 definitions that you must know. Now let us move to the methods of polarizing light. 3 methods we are going to see. उसमें से एक ही method syllabus में है. First method is transmission. Means I have unpolarized light, from something I will transmit, I will get a polarized light. Obviously this is called as method of transmission. You transmit it through something, you get a polarized light. Second method is reflection. Means I will put unpolarized light and reflect होने के बाद it will become polarized light. That is the reflection method. Scattering में, if I put unpolarized light on tiny particles or on irregular surface, after scattering, the scattered light will be polarized light. This is the method of scattering. In our syllabus, the focus will only be on reflection, polarization of light by reflection, using the concept of reflection. और उसमें ही वो law है called as Brewster's law, which we will discuss in detail. Transmission scattering नहीं है. Transmission में just you must know for information कि transmission में substance through which such substances, ऐसे substances जो light को transmit करने के बाद polarize कर सकते हैं, such substances are normally called as dichroic or doubly refracting substances, जिनमें when light enters, unpolarized वाली light enters, it splits into 2 different rays. One is ordinary ray, other is extraordinary ray. वो दोनों rays, extraordinary और ordinary, उसमें से if you remove ordinary ray somehow, then the extraordinary ray is polarized light. So, but we don't have it in syllabus. Previous syllabus में था 2013 के पहले. 2013 में वो change करके this part is particularly removed. Okay, so don't worry about this. Yes, इसमें सिर्फ polarides का concept है जो theory में आएगा, that I will just explain later on. Polarides, H polaroid, K polaroid क्या होता है, that all the things. Main जो point है अभी polarization जो कर सकते हैं अपन using reflection, that we will discuss now. Okay, so write out the heading polarization by reflection. How to polarize light using reflection concept. See, Brewster, it is also called as Brewster's law. How you can polarize light using reflection. Let us say this is some refracting substance like glass, जिसका refractive index mu है. Okay, बाहर air है, air, जिसका refractive index 1 we consider. और यहाँ पे एक source है जिसमें light unpolarized है. Now if this unpolarized light, Brewster का experiment है, देखो, experiment was very simple. Brewster ने इस glass slab पे, this is normal, उसने लाइट इंसिडेंट करके देखा ग्लास स्लैब पे, and the light after incident, we know that light should enter the medium because it is traveling from denser to rarer to denser. It will bend towards normal and all, everything is good. When the light is incident, it bend towards normal, correct? Everything is good. But if 100 rays are incident, remember some rays are also reflected. ऐसे नहीं कि all the rays will go on the other side. Some rays are reflected, some rays are refracted. So Brewster ने दोनों रे स्टडी किए. व्हाट ही फाउंड वाज दिस रिफ्लेक्टेड लाइट वाज पार्शियली पोलराइज्ड. पार्शियली मतलब 100 रेज में 50 इधर गए, ये 50 जो रेज थे वो पार्शियली पोलराइज्ड थे. ऑल वर नॉट ब्रॉट इन अ सिंगल प्लेन, थोड़े इधर उधर वाइब्रेशंस थे. पार्शियली वी कॉल इट एज पोलराइज्ड. सो ही ट्राइड दिस एक्सपेरिमेंट फॉर डिफरेंट एंगल्स, 10 डिग्री, 5 degree, 20, 30 up to 90 ऑल एंगल्स को उसने चेक किया कि ये रिफ्लेक्टेड रे, क्या रिफ्रैक्टेड में इंटरेस्ट नहीं था, रिफ्लेक्टेड रे का बिहेवियर कैसे है. व्हाट ही फाउंड वाज वेरी इंटरेस्टिंग दैट इफ लाइट इज इंसिडेंट एट अ पर्टिकुलर एंगल, एक पर्टिकुलर एंगल पे जब लाइट इंसिडेंट होती है, एक पर्टिकुलर 0 to 90 में एक पर्टिकुलर एंगल पे जब लाइट इंसिडेंट होती है, द रिफ्लेक्टेड रे इज कंप्लीटली पोलराइज्ड, प्लेन पोलराइज्ड at a particular angle, and this angle was named after him, Brewster's angle or polarizing angle. When the light is incident at polarizing angle, the reflected light is plane polarized. The vibrations are in this way, and इस point पे this is reflected ray which will always be equal to R will be equal to IP, and इस case में one more thing happens that the refracted ray, ये जो refract हुई ray है, the refracted ray is normal perpendicular to the reflected one. So ये दोनों कंसेप्ट यूज करके if you write Snell's law, what is Snell's law? Sin IP फर्स्ट मीडियम का साइन इंटू इसका रिफ्रैक्टिव इंडेक्स विच इज 1, क्लियर है ना, इज इक्वल टू साइन दूसरे मीडियम का रिफ्रैक्टिव इंडेक्स कितना है, म्यू है, एंगल इज आर इंटू म्यू. सो म्यू कितना आएगा, साइन IP बाय साइन आर. लेकिन IP और R, ये IP है बिकॉज IP इज इक्वल टू IP और R का एडिशन 90 होना चाहिए बिकॉज इज 90. सो इफ यू रिप्लेस दिस R एज 90 माइनस IP, what you get is cos IP, and that is you get tan IP equals to mu. This law is called as Brewster's law. What is Brewster's law? Brewster's law is tangent of polarizing angle is equal to refractive index of the medium. Means if I explain it exactly in other sense, if I say ये जो ग्लास स्लैब है इसका रिफ्रैक्टिव इंडेक्स है √3, करेक्ट, if the refractive index is √3 tan IP, तो क्या आएगा IP का वैल्यू, IP is equal to 60. इसका मीनिंग ये है कि ऑन दिस ग्लास स्लैब अगर मैंने लाइट 30 डिग्री से डाली, नथिंग विल हैपन, रिफ्लेक्टेड रे विल कम, रिफ्रैक्टेड रे विल कम, नथिंग विल हैपन. बट 60 डिग्री पे एग्जैक्टली व्हाट आई विल एक्सपीरियंस इज एग्जैक्टली 60 डिग्री पे रिफ्लेक्टेड लाइट जो है इट विल बी कंप्लीटली पोलराइज्ड. नो अदर एंगल, 0 to 90 में नो अदर एंगल, ओनली 60 डिग्री पे यू विल गेट प्लेन पोलराइज्ड लाइट. सो दिस फॉर्मूला will be helpful for solving numericals based on polarization of light using reflection. Okay, so this is Brewster's law. Okay, so the last point of this lesson, that is Doppler's effect in light, right? So Doppler's effect in light, what is Doppler's effect in light? We have also studied this effect in sound, right? So Doppler's effect in light and Doppler's effect in sound are both similar. There are only certain differences, small differences. The first difference is Doppler's effect in light is symmetrical and Doppler's effect in sound is asymmetrical. What is meaning of symmetrical? Symmetrical means agar source, Doppler's effect you know, right? Source and observer, if they are moving relative to each other, then observer jo frequency apparent frequency जो hear करता है वो original frequency से different होता है. Means either it is greater than true frequency or it is less than true frequency, the apparent frequency. So in sound what we have seen, if a source and observer are moving relative to each other, okay, then if the source and observer are moving towards right or if they are moving towards left, दोनों केस में you will get different answers. But light के केस में वैसे नहीं है. Light के केस में if relative velocity is same, you will always get the same answer. Means light में it is symmetrical. Why it is so? Because in case of light, the speed of light is constant for all the observers. Whereas sound में the frequencies are measured or the speed is measured relative to the medium. It is dependent on medium. Light में वैसे नहीं, light में it is independent of medium and it is same for all observers. So this is the major difference कि the Doppler's effect in light is symmetrical. First important point. Now second important point is, as we know that if this is observer, this is source and source is going away from observer. If it is going away means इसको जो frequency आएगा, apparent frequency will be less than true frequency, correct? So if the source is going away, the frequency that is heard or seen in case of light, the frequency that is received apparently is less than the true frequency. And if the source is traveling towards observer, the frequency apparent will be more than the true frequency. ट्रू फ्रीक्वेंसी से ज्यादा सुनाई देगी या दिखाई देगी. इन केस ऑफ फ्रीक्वेंसी, मोर फ्रीक्वेंसी विल बी observed. So Doppler's effect in light में, remember this thing, when the source is going away, the frequency decreases, means the wavelength increases because speed is frequency into wavelength, and wavelength increases when the source is going away, and when the source is coming towards, the frequency is increased, means wavelength is decreased. This increased wavelength is termed as redshift. रेडशिफ्टचा मीनिंग असं नाहीये की द ऑब्जेक्ट अपियर्स रेड. नो, ऑब्जेक्ट अपियर्स रेड शिफ्टेड मीन्स फ्रिक्वेन्सी वेवलेंथ इंक्रीज झाली असं वाटतं. मीन्स इफ आय राइट इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम ओवर हियर, गामा, एक्सरे, यूवी, विबग्योर, उसके बाद क्या है, इंफ्रा, माइक्रोवेव एंड रेडियो वेव. इफ अ पर्टिकुलर ऑब्जेक्ट इज वॉयलेट कलर एंड इट इज रिसीडिंग अवे, दूर जा, उसका वेवलेंथ इंक्रीज होगा. वेवलेंथ इंक्रीज होगा मींस इट विल गो टुवर्ड्स ब्लू. सो इवन दो इट विल अपीयर ब्लू, स्टिल वी विल कॉल इट एज रेड शिफ्टेड. व्हाई डू वी कॉल इट एज रेड शिफ्टेड? बिकॉज उसका वेवलेंथ ट्रू से इंक्रीज हो गया. वेवलेंथ इंक्रीज हो गया बिकॉज फ्रीक्वेंसी रिड्यूस हो गया, because the object is going away. So far going objects are generally red shifted. It doesn't mean they appear red. Even ultraviolet emitting substance, light, ultraviolet emitting object, if it is going away, it might appear green, it might appear blue. Okay, so red shifted का literal meaning ऐसे नहीं कि it should be red in color. Red shift means it is going away from us, so wavelength is increasing. Similarly, if the object is coming towards us, तो उसका frequency will increase, wavelength will decrease. Wavelength decrease means it is blue shifted. Okay, the word blue shift and red shift should not be taken literally. Remember, red shift means increasing wavelength. Okay, I can say it in this way: gamma, say red shifted, X-ray is redder than gamma, ultraviolet is redder than X, violet is redder means more wavelength. Okay, इससे ज्यादा, so redness is increase in wavelength. The red shift means the wavelength increases. And I can say it in this way: red से bluer है orange से bluer है yellow से bluer है green से bluer is blue से bluer is indigo से bluer is violet, and so on. UV is more bluer than violet, X-ray is more bluer than more bluer than UV. So left shift is blue shift, right shift is red shift. Simple terms. Clear? And in Doppler's effect, we don't have numericals in state board textbook, but if the question comes, then you must remember this formula, a single formula, that is the change in frequency. I have used F over here, I am using nu, upon original frequency is equal to change in wavelength upon original wavelength is equal to velocity of object, relative velocity of object upon speed of light. Now, this will give you change. Remember, this will give you change. It is up to you कि whether you should add it or subtract it. म्हणजे कॉमन सेन्स सांगतो तुम्हाला, कॉमन सेन्स आहे की इफ ऑब्जेक्ट इज गोइंग अवे आणि तुम्हाला चेंज आला, तर दॅट चेंज यू विल subtract from the original frequency, because object लांब झाले तर frequency should reduce. So this formula will only give you the change. प्लस वापरायचं, मायनस वापरायचं, थोडंसं कॉमन सेन्सचा क्वेश्चन आहे. आपण तुम्हाला एक क्वेश्चन सॉल्व्ह करून दाखवतो बघा, लगेच क्लिअर होईल आयडिया. लेट अस कन्सिडर ऑब्झर्वर अँड सोर्स. सोर्स इज कमिंग टुवर्ड्स ऑब्झर्वर at the speed of 3 into 10 raised to 6 meters per second. 3 into 10 raised to 6 meters per second एक सोर्स ऑब्झर्वर कडे येतोय आणि सोर्स ची वेव्हलेंथ आहे 6000 अँगस्ट्रॉम युनिट. 6000 अँगस्ट्रॉम युनिट त्याची वेव्हलेंथ आहे. तर या ऑब्झर्वरला किती वेव्हलेंथ दिसेल? पहिलं तर या ऑब्झर्वरला तो ब्लू शिफ्ट दिसेल का रेड शिफ्ट दिसेल? जवळ येत असेल ना तर फ्रिक्वेन्सी इंक्रीजेस म्हणजे वेव्हलेंथ डिक्रीजेस म्हणजे तो ब्लू शिफ्ट दिसेल. म्हणजे ऑब्व्हियसली आन्सर 6000 पेक्षा कमी, 5700, 5800, 5900, समथिंग लेस देन 6000. ओके, तर ते कसं काढणार? यूज दिस फॉर्म्युला. सिन्स वेव्हलेंथ दिली, आय विल गो विथ दिस फॉर्म्युला. चेंज इन लॅम्बडा अपॉन ओरिजिनल लॅम्बडा इज v by c. स्पीड ऑफ लाईट तर सगळ्यांना माहिती आहे, 3 into 10 raised to 8. स्पीड ऑफ ऑब्जेक्ट काय? हा तर रेस्टला आहे, सो रिलेटिव्ह स्पीड काय? डिफरन्स 3 into 10 raised to 6 is delta lambda by lambda. Correct? 3 3 गेला, 10 raised to 6 upon 10 raised to 8 is 1 by 100 is delta lambda by lambda 6000 वरती जाईल into 6000 angstrom unit. Don't convert into meters. Keep it in angstrom. 0000 गेला तर आन्सर आलं 60 angstrom unit. This is change in wavelength. आता ही चेंज इन वेवलेंथ तुम्हाला फॉर्म्युला देईल, बट आन्सर फॉर्म्युला नाही, आन्सर कॉमन सेन्स देईल. मला सांगा दिस 60 angstrom unit I should add in this or subtract in this. तर ते मी मगाशी सांगितलं तसं लॉजिक. If the source is coming towards us, त्याची फ्रिक्वेन्सी will increase, wavelength will decrease. So minus 60 करून final answer will be 5940 angstrom unit. This is the wavelength of that source that will be appeared, that we will see from observer's point of view. Correct? So how to use this formula है त्याचा example आहे. This is all about Dopplers effect in light, and this is the theory of wave theory. This is the theory of the lesson wave theory of light. Now we will switch to the second part of this series, that is solving previous year's MCQ questions, and then the last आहे assignment मधले questions.